the pictures, you'll usually have a thumbnail that's stored in the picture. So you'll look at something and you'll look, because they'll still look to your software as extracting the data. It'll still look like a JPEG. It'll just be a small one. So in this particular case, this was a thumbnail. It was a small thumbnail. It's 64K. So that thumbnail came out, but the original picture that was larger than that actually looks like this. So again, you start looking at it going, hey, I could start to tell what the stripe sizes are. Or you start looking at things like this. This is a thumbnail that came off the drive. Again, it was this one's like around 80K or so, and you can start to see it's intact down to the spot that actually starts to look like it's around 64K stripe sizes. You start getting big pictures, they start to look like this. You start getting like a little chopped up thing. So this is the kind of thing where, like, anybody seen Greg Conte talk before? So Greg Conte does all these, like, I'm doing analysis of data, and I do it visually, and he, like, takes packets and throws them up, and you can tell what's going on. Well, that's the same kind of thing you start to see here. You start getting, well, I know that now I've got these blocks of stripe sizes that are the same, and then I've got this rotation that's actually moving, and you can start to see as you're looking at pictures and images, like, okay, so right here, this is part of her face. Is it actually in the picture? Does it belong? It actually is part of the picture, and it's rotated through the slice. So in this case, we're looking at things that might have an arrangement order, a problem with the arrangement because the content actually belongs. Then you get to, like, really large files, like 10 meg files. And so you start seeing these chopped up things as they come from different segments of different pictures. So it starts to make sense. So once you finally get that, you'll actually get something that looks like this. So your goal is obviously to get to a spot where you can actually see the picture. So I'm going to start here on RAID 0. RAID 0 and RAID 5 are fundamentally the same from a standpoint of figuring this part out, other than the actual arrangement itself. So I'm going to start with an MP3 sample, and then I'm going to do the demo actually on RAID 5 after we cover RAID 5. So here's my MP3. So if you have files, and most of us have like iTunes directories and stuff that are on our box, if the files are next to each other when you extract them, they do a similar thing that the JPEGs do. They'll play a chunk, and then they'll play another chunk. And the chunks won't be together, and they won't make sense, but it'll come off as one file. So if you happen to have 70s porn on your hard drive or something like that, and you were to play it, this is the kind of stuff you'll get. And it'll sound like a long sample, but trust me, it's only like 40 seconds. It'll be enough.
A relaxed ass is a happy ass. But if it's a tight and unrelaxed ass, it's an unhappy ass.
All right. So that's pretty much the way that goes. You'll get a lot of that. Anybody know who that last one was? Come on. You guys know Ron Jeremy. Don't act like you don't look at porn. Whatever. You're all in this talk. We know what's going on. Trying not to admit that. I told her she was going to be really popular. And we'll put her phone number up. No. All right, so let's talk about RAID 5 for a minute. This one's a little drier, but let's get this out because it's that's the important part. So basically the first thing is controllers. It's really helpful if you know what your controller is, but fundamentally there's two different types of controllers that you have to pay attention to. And one is whether or not you actually have a host controller or a discrete controller. If you have a discrete controller, it basically means I have a processor on my RAID controller because there's going to be all this math that the functions actually have to be done to actually make this array work. If you have a host-based controller, you know, people think, oh, a host is great. I can take like 8 of my IDE hard drives and I can add them all up. The more drives you add to a host-based controller, the more CPU power it's using from your CPU to actually do these calculations. Whereas the discrete controller actually is able to do the calculations for you to produce that content so that it's not actually impacting your system. And we're going to try to do all this in software. So the whole point is the more drives you have in your RAID array, the slower and the longer it's going to take to do these mathematical calculations in RAID to produce it. So we're going to talk about those in a minute. So the whole point of RAID 5, obviously, is that you want to keep your server up. You want to have some time where my data is redundant and that my system can continue to run. I have a drive that's died, and that I'm going to replace it if one of the drives dies, but my system continues to run. But now the reason that you're seeing the RAID array in for some kind of recovery is usually one of these. The guy had one drive go bad, and the alarm goes off. And the boss is walking by the door, and he goes, "What the hell is that damn alarm? Turn that crap off. That is so annoying." And they turn it off. And then what happens? Everybody knows what happens after that, right? 6 months later, drive number 2 dies. Then you have a problem. And that's why it's in for recovery. Now, here's your big problem when you're dealing with this. If you have 2 drives that have died in a RAID array, so RAID arrays, typically you have to have a minimum of 3 drives. So usually 1 drive can die, and you'll be fine. So however many drives you have in your RAID array, 1 drive can die, you'll be fine. You can do this reassembly and do whatever. 2 drives die. Which drive do you have to have? The one that recently died. The last one is the one that has to be there because that's the one that has all the data that's synced to it. The oldest one that died is completely worthless. So if you don't know which drive died, because where are the log files for where the drive died? On the damn drive. Right. This is a great reason to actually copy all these log files maybe periodically, put them in a backup tape somewhere or something. Anyway, but you need to know which drive died last, or you're kind of screwed because you're going to rebuild 2 drives. You're going to spend twice as long actually getting this job done. So the less you know, the worse off you are. So basically, it looks a little bit like this. You've got a stack of drives, and data parity is basically rotating through the drive. So there is no parity drive. I hear that all the time, like RAID 5's got a parity drive. No, it's distributed across all the drives. So you could put an X on any one of these drives, and it would be completely dead, and it would be fine. You have all the data that you need to do the calculation. So when you have a system and it's all plugged in, and basically let's take a simple one, like these 3 drives here, you'll actually have the parity distributed. So now this talk doesn't lend itself very well to animation, but I have some. Woo! All right, I just have this one nice fancy one. All right, again, now this is the, see if I can make it fit. All right, there we go. When you're talking about porn, you got to always make it fit. All right, so this is the executive summary version, okay? So, again, take this with a grain of salt. And this is the one you want to show your boss when you're trying to say, I'd like you to buy a fancy RAID array. And in the old days, we used to have to actually convince people. People remember like 2000, 2001, you had to say, we need a RAID array on our server. And the boss was like, why do we need one? Well, this is the sample that you want to give him because it makes it very easy for an executive to understand why you have to have one. Okay? Okay, so the deal is that this is not the exact formula. You guys should all know that by now. It's not the exact formula that it follows. But your boss can understand this. He can get that down. Maybe even photographers. But ultimately what you're looking at is that at any point in time, if you took this formula and you have 1x, people can figure out what's supposed to be in that 1x from the data that exists. So what you actually are doing is an exclusive OR arrangement on these so that you can actually produce that parity. But it's a much more complicated process and requires a very high-speed processor to do it. So this is why having a discrete controller is going to be a much better deal than a host-based controller. Host-based controllers, because they're cheap, they'll do just about anything. They're a mess to deal with. But if you're dealing with a discrete controller, you spent more than $300 on the controller, which means there's documentation somewhere, and it didn't come just maybe from China. I don't know. But at least you've got something that you can read, hopefully, and find out what your arrangement is, or if they did anything strange like an offset or something. So that's my executive summary version. Okay, so this is the simple formula. If you're dealing with this, you actually have an exclusive OR that's actually going to be between the drives to produce the parity. So the exclusive OR is the function that we're trying to deal with from that standpoint. I just said this about the other. So This is the hard part with dealing with RAID 5. You've got so many X's. Besides just the fact that you have an X of which drive died, you actually have these other X's which will become unknown. And hopefully you can eliminate 2 of these so you can try to guess what the other ones are. Because you'll